Alright, so we are going to look at friction forces. It's a little bit of a review, but I just want to make sure that you have all the correct information and that you understand the information. If you have any questions, please send me questions in Schoology message or call me so that we can discuss them and hopefully get you some clarification for the pieces of information that I haven't made clear to you. Alright, so let's go ahead and get started. Our agenda is to get through, we won't be doing a do now, but we will be working on the friction review worksheet, so you might want to have that open as we go through this. I'm going to tell you at different points to pause the video so that you can spend that time working on those you do sections on the worksheet. So I'll give you some information and give you a couple you do questions to work on the worksheet related directly to the information I just gave you. Hopefully that'll help you really kind of solidify some of this knowledge. And then we'll have an exit ticket at the end. So I tried to do this in Blackboard Collaborate, but it wasn't importing my PowerPoint. We'll get to the end and tell me that there was an error. So we're going to go this route with the PowerPoint mix. So hopefully that'll work for you. Alright, so friction forces is what we're talking about. So friction is basically, the most basic definition is that it's resistance to the motion of one object relative to another. So it's the resistance to motion of one object moving relative to another. So a box on a table or a box on a floor isn't going to move because of the friction unless a net force is applied to it to make it move in the direction of the greater force. So when you're trying to push an object and you feel this resistance to the object that you're trying to move, this is what we call friction. And you probably knew that before we even started this section, but in case you didn't, there it is. And here's the more scientific definition for it. You probably knew what it was, but maybe not how to explain it. So this is how we explain it. So it's that resistance that you feel resisting the movement that you're trying to create. Alright, so there are two types of friction. Static friction is the type of friction that relates to there being no motion between the object. So if you can't push the box across the floor, if it won't go, I don't know if you can see this or not, then it's static motion, if there's no motion at all. But if there is motion, then we would call that kinetic friction. There's still friction there, even if you reduce the friction, which we'll talk about towards the end. But there's still friction there even though the object's moving. Even in space, there's a little bit of friction. Not a lot, but just a tiny bit. So taking that information, I want you to look at your worksheet and answer those first 4 questions in that you do number 1 section. It should only take you about 2 minutes. So pause the video here, and then when you're done filling out the you do section number 1, then go ahead and click play, and we'll continue from there. Alright, so I'm assuming you're back, so let's move on. When we're dealing with liquids, we have friction that is resistant between the moving layers of the fluid. And so this is also known as viscosity. Motor oils for cars and other engines are rated based on their viscosity. And so that is the amount of friction between the molecules of that liquid, basically. So in liquids, friction is the resistance between moving layers of a fluid, known as viscosity. So the more viscous fluids are thicker. So honey would have more fluid friction than, say, water. It's a great example. So honey is a higher viscosity, has more fluid friction than water does. When we're talking about air, so we're kind of going through the phases, right? So water, gas, this would be gas, but in air, which is gas obviously, in air the molecules of gases in our atmosphere create friction resistance. And there are no completely frictionless environments. As I mentioned before, even deep space does have tiny particles of matter that can interact and cause friction. So static friction prevents objects from moving, and it's generally higher than the frictional force experienced by the same two objects when they are moving relative to each other. So static friction is going to be a higher force, a stronger force that's experienced by those two objects relative when they're relative to each other. Okay? So in other words, when those objects begin to move, the friction that they experience at that point upon moving is actually less. The force is lower. So static friction requires a high amount of force, comparatively. Alright, static friction is basically what keeps a box on an incline from sliding to the bottom. So you may have seen this. If you put a box here, we'll see if we can do it here. So here's some friction. Put the box up like this. It's going to stop at my thumb, but as I tilt the book up, it's still not sliding, and now it's starting to slide. So the gravitational force overcame the frictional force once the box started sliding. So you can see I have it at an angle here, but it's still not sliding. Now if I increase the gravity, this is a little heavier than this is just an empty box. This book is a little heavier, so if I put it on here, I can probably raise it up quite a bit higher before it starts to slide. Okay. Also the texture, these are very slippery, smooth textures, so we've reduced the amount of friction between those two surfaces by the nature of the surfaces themselves, by their texture. Alright, so here's your opportunity to take 3 minutes or so and complete the You Do section number 2 on your worksheet. So pause the video here, and when you're done, come back and press play. Alright, so looks like you're done with that section. So let's talk about a couple other things. So if you were sitting on a steep hill and you press your feet against the ground, that'll keep you in place. It'll keep you from sliding down the hill. So this is where you are taking advantage of friction. When two objects rub together, friction causes some of the energy of the motion to be converted into heat. This is why rubbing two sticks together will eventually produce a fire. Friction's also responsible for wear and tear on things like bike gears, transmissions in cars, and other mechanical parts. Whenever they're rubbing together, they're going to kind of wear each other out. And that's why lubricants or liquids are often used to reduce friction and wear and tear between those moving parts. So to reduce friction, there are three things we can do to reduce friction. We've already talked about these in a previous lesson. But they are to use a lubricant, such as motor oil or grease or water or anything that kind of has a slippery texture to it. And another way is to add rollers. Right? We can put heavy objects on top of round logs and roll them across the logs. Or we can use straws, or even the bearings in wheels for like bicycles and inline skates and skateboards and things like that. That's adding rollers. Imagine trying to skateboard without any wheels or rollers. You would not get very far. And then the other option is to make surfaces smoother. And like I talked about, this book, it's got this shiny cover on it, so it's pretty slippery. But if I took this slippery cover off, I think it's actually called a slip cover, I have a different texture. So where'd my other book go? It's a little bit rougher, so I might be able to actually get more of an angle out of my, oh, there it goes. This is a really slippery cover too. Let's try this. This is kind of slippery as well. It's getting pretty high. There it goes. Or how about my phone has a case on it? Might be a little more tacky. Okay, so it went pretty high before the phone started to move. So you get the idea. Alright, last section of your worksheet. Take about 6 minutes to do this. So press pause on the video, and then when you're done you can press play for the exit ticket. Alright, so here's your exit ticket. The question is, how might have the early Egyptians been able to move such large, heavy rocks across sand to build their pyramids? So you can see there's a girl in the picture there, and she's standing by these blocks. These blocks are about as tall as she is, so probably about 5 foot high. So they're very, very heavy stones that they carved into squares. So how might they have been able to move these across the soft sand? And that's your exit ticket for today, and that's the lesson for today. So enjoy. We're at the end of the marking period, so get as much as you can get done in the next couple days. You have the weekend to finish up. As of midnight Sunday night, all lessons will be locked. You won't be able to submit them anymore, so that I can get grades in on Monday. Okay? If you have any questions, shoot me a Schoology message or give me a call on the telephone. All my contact information is on our course main page up at the top. Thank you.